So, thank you. Yeah, there's like a little bit of applause, not much anyway. So, today, it is January 4th, 2017. Wow, crazy, huh? So, Common Core Standard, what we're going to talk about today is solving trig equations. Alright, today it gets a little bit more complicated. You'll see. Today we're going to have to do some factoring. Keep in mind that when we did this yesterday, we wound up with 2 answers, okay? Today we might wind up with 4 answers. I'm going to show you what I mean, okay? So don't let that bother you too much. The big key is, can you factor? Of course you can. Can you solve? Of course you can. So let's take a look at example 1, okay? So example 1 says solve 2 sine theta minus 1 equals 0 in 1 period. Now in the 1 period, the sign for period is between 0 and 2 pi. That's the normal period for sine, right? We know that if you go all the way around the unit circle, you've gone 2 pi, right? Or if you graph it, do one full graph, right? One full graph, it's 2 pi, right? So I'm just going to solve it like I solve anything. So if I do a little side work here, if I had 2x minus 1 equals 0, if I had to solve this, that'd be pretty easy, right? You would, add 1 and divide by 2, right? That's super easy. So we're going to do the same thing here, except we're going to do it with sine. Okay, so step 1, add the 1. So I have a 2 sine theta equals 1, right? Divide by 2, sine theta equals 1/2. Okay, now we need the angle, so we could either do the sine inverse using the calculator, or Sarah's looking in the right place. If it's on the unit circle, let's use the unit circle instead of degrees. We want to use the radians, right? So 1/2 for the sine value is at pi 6. We agree? So theta 1 is pi 6, and there's another answer. There's 2 of them. The other one's at 5 pi 6. Agree? So theta 1. Theta 2 is 5 pi 6. Okay? Easy. Now it says for all solutions. So if we were to go ahead and let this thing go forever and ever and ever, because the graph looks something like maybe this. I mean, a sine curve looks like this, but it keeps going and keeps going and keeps going and keeps going, right? So there's lots of places this could have some answers, right? So it can have an infinite number of answers. So what we're going to do is this. We're going to say, okay, one answer is pi 6 plus 2 pi k. Remember the k? The k represents the numbers 1. So k represents the numbers 1, 2, 3, 4, dot, dot, dot. And what this allows is we get the first answer here, pi 6. We'd have another answer here, right? We'd have another answer here, and so forth and so on. But now we have a 5 pi 6, right, plus it's 2 pi k also. So here's our 5 pi 6s right there. Then we'd have another answer here. We'd have another answer here, and so forth and so on, okay? All right, how's that? Not bad? Okay, example 2. Solve tangent squared theta minus 3 equals 0 in 1 period. Now, the period of tangent is between 0 and pi, right? Okay, tangent doesn't go all the way to 2 pi. So let's see what we get, okay? So, step 1, let's go ahead and minus 3. So we get tangent squared theta equals 3, right? That makes sense. What am I going to do next? Square root it. Guys, okay, square root. So I get tangent of theta equals plus or minus the square root of 3. Plus or minus because you can have a positive and negative answer, right? A little side work. If I had, say, x squared equals 4, you know that x could equal 2 or negative 2 because the square root of 4 is 2 and negative 2, right? You get both answers, okay? Same thing here, okay? Same thing here. We get plus or minus. All right, now, I could use my calculator. I could, but it's on the unit circle. Now, if you remember from last year, I'll leave you with last year, right? From last year, we learned that the tangent values, those are the pink ones on the unit circle, on my circle, right? So I see one answer, pi thirds, right? Theta 1 is pi thirds, right? And the other answer for negative pi thirds would be at 2 pi thirds. And theta 2 is at 2 pi thirds. Okay? How's that? Do you see it? Negative 2 pi. Do you see 2 pi thirds up there? See the pink? I got a square root of 3 at pi thirds. I got a negative square root of 3 at 2 pi thirds. Everybody good? Everybody show them, right? Got it here.
Is that a square root of 3 at 4
It is. So I got one here, right? And I got one here, right? And then actually, if I wanted to go another period, I could also say I've got one.
Oh, because it only
Here.
goes one.
Right? I got, and it's okay. In fact, I want to put them down anyway. Pi thirds, 4 pi thirds, and you're totally right at 5 pi thirds. So I also have, and I can add more. There is and. I'm going to put and. I like Jose because overkill is never bad, is it? Adding extra answers is never bad. So if I wanted to go say theta 3, I could say, well, gosh, there's one at 4 pi thirds. And we can say also that we've got one at 5 pi thirds. Nice job, Jose. We can add those, okay? I think all we need is these two, but it's okay to add those as well, okay? All right, you guys ready to turn the page? Not too bad? Oh, boy. I think that looks kind of familiar. I do. I think that looks kind of familiar. In fact, if I take a look at what we did in our reading, I think that looks maybe a little bit like that, doesn't it? Remember when we did our reading? It looks a little bit like that. So solve my 2 cosine squared theta minus 7 theta cosine theta plus 3. Let's factor it. So again, if I do a little side factor on the side, it doesn't hurt to go say, okay, well, it's a 2x squared minus a 7x plus 3. Would factor into, we've done this. I like a little side work, doesn't hurt, right? Would factor into a 2x x. We'd go a minus 1 and a minus 3, right? But that's with x's. And sometimes it's helpful just to think about it in terms of x's and factor it like we did in algebra, right? If I did it in terms of x's. But then that helps set us up for the cosines, right? So this is my little side work, okay? Keep that to the side. So what I'm really factoring, though, is a 2 cosine theta, right? I'm going to go my minus 1 and my minus 3 equals 0, okay? 2 cosine squared. There's my minus 6, and my minus 1 makes my minus 7, right? And positive 3. Okay, that's exactly what we did in our reading. So we checked it, and we showed that it works in our reading, right? Are we good on that? Let you catch up and write that down. So if it's factored, what we're going to do now is set it up into 2 little equations, right? So we're going to go ahead and rewrite this as a 2 cosine theta minus 1 equals 0. And a cosine theta minus 3 equals 0, right? Okay, Quinn's back there wide awake. Okay, let's solve.
Yeah, Quinn.
Plus 1, I get a 2 cosine theta equals 1, right? Divide by 2, I'll have a cosine theta equals 1/2, right? I'll let you catch up, good. And then I can either use my calculator, which works, and my reference sheet. I mean, reference sheet, calculator, it all works. But if it's on the unit circle, right? If it's on the unit circle, let's just use the unit circle. So, and it is. So I don't need my reference angle sheet because it's on the unit circle. So 1/2 for cosine, it's the x value is at pi thirds. So we'll go theta 1 equals pi thirds. Okay, 1/2 for cosine. Cosine is the x value. And 1/2 for cosine is all the way down at 5 pi thirds. You see it way down there, 5 pi thirds? So theta 2 is at 5 pi thirds. Okay? You guys want me to show you? So cosine is the x value. So here's 1. Here's my 1/2, right? And then here's the other 1/2 right there, 5 pi thirds. Everybody good on that one? Okay, so those are my first 2 answers. Now, on the second one, let's do the second one. So then solve and go, okay, cosine theta equals 3. Can't be. Can't be. If I knew I had an x value, what's the furthest out I can go?
1.
Can I get to 3?
No.
No. So what do we do with this? We throw it away.
Undefined.
Yeah. So cross it out. We just get those 2 answers, okay? All right. I think we're doing pretty well, huh? Everybody good? Thumbs cut sideways, they're kind of up, kind of down. All right, I see some down. That's right. We're going to keep working on it. All right. Let's keep working. Example 4, right? So solve 5 sine theta cosine theta plus 4 cosine theta equals 0. Okay. Looks familiar, doesn't it? Looks familiar. Okay, it looks like what we did in our reading, right? It looks very familiar. Of course, I did that on purpose. You know me. No mystery to me. So if I did a little side work, if I really had the 5xy plus 4y, then obviously they have a y in common, right? You need to factor out the y. We rise a 5x plus 4. But that's my side work. I don't really need that because what I'm really doing is sines and cosines. So let's look at it. What do the 2 terms have in common? Cosines. So let's factor out a cosine theta. So I'll factor out a cosine theta, right? If I common factor out the cosine theta, what's left inside? Well, if I take out the cosine, I'd have a 5 sine theta plus 4 equals 0, right? All right. We've got 2 little mini equations. Let's set them both up equal to 0. So let's go cosine theta equals 0 and 5 sine theta plus 4 equals 0. All right. Cosine of 0. Cosine is the x value, right? And it happens at pi halves and 3 pi halves. Happens at pi halves, so cosine of 0. There it is. X value, pi halves, right? Cosine is the x value, 3 pi halves, right? Okay, those are my first 2 answers, okay? Theta 1, theta 2. So theta 1's pi halves, and theta 2 is 3 pi halves. All right, it's no problem. Second one, let's solve. So minus 4, right? Solve a 5 sine theta equals negative 4. Divide by 5, divide by 5. Sine theta equals negative 4/5. Okay, now that is not, it's not on the unit circle, right?
Awesome.
So let's use our little sheet, right? Our little, reference angle sheet. So I've got that. So I have sine of theta is equal to a negative decimal. That's what I really have, like, right? Negative 5/4. So according to my sheet, I'm going to do sine inverse of that answer, but then I'm going to have to add the 2 pi to it, right? So let's do that. Let's go ahead and take my sine inverse of my negative 4/5, right? Oops, that's not going to work. Let's try it again. Sine inverse of negative 4/5, right? So I got a 0.9, but again, we have to have it between 0 and 2 pi. So my reference angle says, okay, well, take that answer and add 2 pi to it, okay? So I'm going to go plus 2 pi, okay? So I get an answer of my next angle, let's call it theta 3, what the heck, is about a 5.36, I guess, or I round it up, okay? Now, theta 4, it gets tricky with a sign, but let's make sure we understand what's going on. So the reference angle says take pi plus the absolute value of the original calculator answer, okay? All right, which one's that? That's my negative 0.92, okay? Does that make sense? So I'm going to take, then, my theta 4 is going to be pi plus the absolute value of a negative 0.927, blah, 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 blah. Well, it's really actually 9 plus that, right? Because the absolute value of that makes a really positive answer. So I'm going to go then pi plus my 0.927, and I can answer about 4.07, I guess. 4.07. There's theta 4. All right? What do you think? I would work with these with you, but I need to go over and teach those little freshman kids.